Okay, here we go for the last class of the semester for discrete math in English. And we have tons of things to do today. First of all, please everybody answer the final survey thing. I'm going to link it here again. It's very similar to the one we did in the beginning of the semester and the one that we did right after the midterm. So you guys can go filling that in. Then after we do the practice of the final exam, if you want to register a project topic, that would be important to do because this will be your last occasion to do so. And the main thing to do today is we're going to answer the entire final exam in practice mode. So we're going to first rush through the questions that we learned about last week, and then we're going to pay more attention to the details of the questions we didn't practice yet last week. So let me make an exam in English for myself here. And as you guys already know, you urgently need to see my graph to be able to know what exactly I'm doing. So I'm going to give you a screenshot of the first three questions. And if you understood everything last week, then you can just answer the questionnaire and kind of semi-pay attention to what I'm doing. If you struggled last week, it's better to pay attention to what I'm doing now and worry about the questionnaire later on. But let me head to the whiteboard. Remember to vote red if you get horribly confused, yellow if you need me to go a little slower, and green if everything is okay. So the very first thing we need to do is draw this graph, and once it's drawn, we can answer the first 12 questions based on that. So first I'm looking at my graph for a little while to figure out what vertices have a lot of connections. It looks like A has a lot of connections. So let's put A here in the center and then worry about the connections that go to A. We have, for example, AD and AC. So let's put C on one side, D on another side. I'll put the weights later on in a different color. A is also connected to an H. Okay, and C is connected to a G, and that G is connected to an E. I have a B connected to D, and then B is also connected to F. Okay, I'm already changing my mind about where these things go. Let's put E here, so I can put H here, so that I could put the B was with F and D was with F. So B and D both need to be close to F. And then C is also with F. So let's put C with F, D with F, and also B is going to go with F. Okay, let's start looking at how many of my edges I have already located. So the first one's the C to G. C to G has a weight of 2. Then there's a B to D. Okay, I don't have that one drawn yet. B to D. Let's move B a little closer here. B to D. That one costs 6. Then I have an E to G with a cost of 5. B to F has a cost of 7. I have an F to G. Okay, F to G, we have to draw that one. So let's move G over here, E over here, so that the E to G5 can be here, and the G to C2 can be there, because this makes it easier for me to connect F and G, and the connection between F and G is going to cost 8. Then the A and D costs 1. CF has a cost of 5. Then I have an AH. It has a cost of 5. AC has a cost of 5. DF has a cost of 3. And then I have an FH. I don't like this. FH is going to cost 4. So what I'm going to do is I'm going to move my A upward so I can fit H down here. So we're actually going to put A up here with this 5 and this 1. And we're going to put the H down here. So A goes up, H goes down. So now I can connect the F with an H, and it has a cost of 4. Since I made a lot of changes in the drawing, it's a good idea to go over those changes and make sure we didn't mess anything up. So let's go through the graph one more time. CG connected with 2. BD connected with 6. EG connected with 5. BF connected with 7. FG connected with 8. AD connected with 1. CF connected with a 5. AH connected with a 5. AC connected with a 5. DF connected with a 3. And FH connected with a 4. Okay, so the drawing seems to be good. I'm going to send you guys a picture of it. And now remember, the first 12 questions are going to be from this picture. So take all the time you need to draw a decent picture, and then you start answering the questions. Remember, we have to write down all of the options we pick. So I'm just going to write the first 12 now because they come from this graph, and we're going to be very quick because we need more time for the second half. So what's the order of the graph? That's how many vertices I have. I have 1, 2, 3, 4, 5, 6, 7, 8 because I have the letters until H. So N is 8. Let's write it down here. N is 8, and that's option E. 1E. Okay, what's the size of the graph? That's how many edges I have. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 edges. So M is an 11, and that would be 2D. Then we need to calculate the density. And remember, that's twice the M divided by N multiplying N minus 1. So I have a 2 times 11. Then I'm dividing by the product between 8 and a 7. We can simplify. I can take this 2 out from this 8, so it becomes a 4. So I have an 11 here, and I have a 28 underneath. So 11 divided by 28, that would be 3E. We're not taking pictures of every step anymore because remember, we already did this last week. You can watch last week's video if you don't remember how this is done. I'm going to get you guys a screenshot of the next batch of questions that are still about the same exact drawing. Putting it on Discord. We're going to calculate the average degree. We're going to work with an induced subgraph, pick a cycle. Then we're going to work with the maximal click, and then I'm going to take another screenshot of the remaining questions. Okay, so what's the average degree? Now remember, for the average degree, you could either calculate all the degrees and then divide the sum by how many vertices you have. Or if I sum all of the degrees, I'm always going to get 2m. Why do I get 2m? Because I will count each endpoint twice. So if I divide 2m by n, I also have my answer. So I had 2 times 11 divided by an 8. That's going to be my average degree. So it's an 11 divided by a 4, which is 4b. Then, how many edges does the subgraph induced by GAFH have? Okay, G, A, F, and H. Yeah, GAFH. how many edges connect these guys in particular? There's the G to F, there's the H to F, and there's the H to H. They have no other edges amongst these guys. So I have 3 edges. That's 5D. Then we need to pick a cycle. So let's look at the options. DAC. DAC is not a cycle because C and D do not connect. Then HFGE. HFGE, also not a cycle because E doesn't connect to H. HAD. HAD, also not a cycle because H and D do not connect. So we have one more option, and it starts with E. E is not going to be in any cycle because there's no way to get back once we left. So the correct option is going to be that there is no cycle, which is 6D. Okay? Then which of the following is the largest maximal clique in G? Remember, clique means everybody's connected to everybody. Maximal means there's nobody else that's connected to all of those. And largest is simply that it has the most amount of vertices. So AC, that's definitely a clique, and it's also maximal because there's no triangles I can do with A and C. Then FDB. FDB, it's also a clique, and it's larger than this one because it has 3 vertices in it, and there's nobody else that could go there. So FDB is a very good candidate here. So it's definitely not going to be 7A nor 7C. So let's look at the other ones. We have FGC. FGC is also a clique of 3, and it's also maximal. And then there's the DB, which is also a clique, but it's not maximal and it's not largest. So we can pick either 7B or 7D, and both should be correct. So we can pick B or D. Either one goes. And we need another screenshot of the remaining questions that come from this particular picture here. There seems to be a cat fight in the living room, but my boyfriend's on it, so we'll be fine. Okay, so which of the following is the largest independent set? Remember, this is the opposite of clique, so we need no edges among the participants. So BCD, it's not an independent set because B and D are connected, so that won't be an option. Then we have a really big candidate that has H and B and then D, but B and D are connected, so it can't be independent set. Then we have an HE. HE is an independent set. It's kind of tiny, but it is. Then I have an A, F, C. Well, yeah, it can't be because both A and F are connected with C. So the HE is the only one of these options that's actually an independent set. So we are picking 8D. For 9, we need to figure out the greatest connected component. Once again, I have a connected graph. If I didn't have this edge here, then I would have 2 separate components. But this graph is, again, its own largest connected component. So we are picking 9D because I have 8 vertices and they're all connected to one another. For question 10, I needed the weighted distance from F to E. This is F, this is E. If I go straight, it's 8 plus 5, but I can do cheaper by going 5 plus 2 plus 5. So 12 appears to be the cheapest way to get there, and 12 would be option C. In 11, I need the weighted diameter. And remember, we're going to do this by elimination. So it's definitely not going to be many of these options. Let's look at this. We have an option that's 19. We have one option that's 5. We have an option that's 2. We have an option that's 4. And we have an option that's 6. We already know that the shortest path from F to E costs 12. And the diameter has to be larger or equal to 12. So it can't be this, it can't be this, it can't be this, it can't be this. I don't have to do any other calculations except saying, since the weighted distance from F to E is 12, it can only be option A. It cannot be anything else. And remember, if the elimination doesn't work, you're just going to make the distance matrix like we did last week. You can watch the video if you don't remember how. And then the question 12 is the cost of the minimum spanning tree. And we do that by using the cheapest edges first. I need another color. Let's use pink. So I'm going to connect with the cheapest edge first. That's A with D. It's going to cost me 1. So now A and D are connected, and I paid this 1. What's the next cheapest edge? I have a 2 over here. Let's pay 2 to connect C to G. Okay, there's no more 1s and 2s. I'm going to pay 3. Paying 3 to connect F with both D and A. Lovely. No more 3s available, but there is a 4. I'm going to pay a 4 to connect H with F. And now, since there's already a way to get from H to A, we will never use this edge. So we're just discarding it entirely. No more 4s available either. I need to use one of the 5s. Doesn't really matter which one I use first. Let's use this one because it's inevitable. There's no other way to get to E. Thank you for the cat attention. So now I have little components here. These 3 guys are connected and these guys here are connected. And I can use either one of these 5s to connect those 2 islands. It doesn't matter which one. So let's use this one here. So I pay 5 to connect them. So now I'm discarding edges again. I'm never going to use this one because F and G already have a way to get to one another. Never going to use this one because C and A already have a way to get to one another. So now my only remaining edges to consider are the 6 and the 7. I take the cheaper one, that's a 6, to connect to B. I pay the 6, and now since F and B already have a way to connect to one another, we're never going to use that edge. So I ended up with this tree here. We need to calculate the total here. I have a 10, I have a 20, I have a 26 total, and that would be 12A. I'm going to take a picture of the spanning tree just in case. And then we're going to do the part that corresponds to today. Picture. Could you guys vote green if you're pretty much okay with the graph stuff? Vote yellow if you think you'll be okay once you've watched last week's video again. Red if there is something that you simply do not understand even though you paid attention last week. And if we're all okay, we can go on to the second part. I have no idea where my water bottle is. There's one right here. Okay, 5 people are okay. I'm going to ban a spammer on Twitch, and they're gone. Okay, I'm going to get you guys a screenshot of what we are doing next. So this is stuff we haven't looked at before in the exam, but it's related to things we did in homeworks 4 and 5. I don't see anybody on yellow or red, so we are simply going to continue. I kind of like the end of the semester because the people who are not studying already kind of gave up, so I only have the cream of the crop with me, and everything's so easy. So now we're going to be answering questions 13, 14, 15, 16, 17, and 18 based on our second drawing. And we are again going to spend a lot of time making sure that the drawing is okay. And once the drawing is fine, we will start answering the questions. So remember, when we're building a binary tree, the very first node will become the root. So the first one in the sequence, 59, it's going to go into the root. So this already gives us the answer for question 13. What's going to be the root? It's always going to be the first one in the sequence. So in this case, it's 59, and that's option E for question 13. The next question we cannot answer until we have actually drawn the whole tree, because we need to know how many leaves we have. So let's put the other keys here. Remember, everybody always enters through the roots. There's no other way in. Smaller goes left, larger goes right. So 49 comes in, it's smaller, it goes left. Then a 95 comes in, it's larger, it goes right. Then we get a 55. It's smaller than this one, but larger than this one. So it goes once left and then it goes right. Then I get a 96. It's larger and larger, so it's going to go right both times. Then I'm getting a 5. Smaller, smaller, left 2 times. Then I'm getting a 15. Smaller, smaller, larger. Then a 24. Super important. Always go through the root. Do not cut. If you take shortcuts, you will mess it up. Smaller, 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 larger, larger. 24 goes over here. And 61. Larger, smaller. 61. 7. Smaller, smaller, larger, smaller. 13. Smaller, smaller, larger, smaller, larger. 13. 19. Smaller, 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 larger, smaller. 19. If you cut corners, you will mess this up. 3. Smaller, smaller, smaller. 6. Smaller, smaller, larger, smaller, smaller. 38. Smaller, smaller, larger, larger, larger. 38. 14. Smaller, smaller, larger, smaller, larger, larger, and larger. 92. Larger, smaller, larger. 92. And a 90. Larger, smaller, larger, smaller. Okay, I have made a tree. So now the stuff we already knew, that the first one was the root. Then anybody who doesn't have anybody hanging from them are leaves. So I now have all of these leaves. And pay attention, sometimes the leaves are very high up. It's very easy to miss these. Leaf doesn't mean it's low. It just means nobody else hangs from it. So how many do I have? 1, 2, 3, 4, 5, 6, 7, 8 leaves. And that's option E for question 14. Taking a picture. Resetting the votes. Please vote green if you understood how to make this drawing. Please vote red if you think there's an error in my drawing or you have no idea what's going on, and write about it in the Twitch chat or the Discord chat. And yellow if you think you'll manage it when you're rewatching this video. But it's super important to be okay with this drawing, because none of the remaining questions here really make any sense if you don't understand what's happening with the drawing. Okay, 3 people are fine with this. Everybody else is eating taquitos. If your drawing is fine, the next 2 questions are absolutely trivial. What is the parent node of 5? It means look at where 5 is hanging from. 5 is hanging from 49. That's option D. And if you're looking at this in the exam and you're like, well, it's none of those. What does it mean? If it's none of those and there is no word none as an option, your drawing is wrong. It has to be one of the ones I'm providing. If it isn't, you need to redraw. What is the left child of node 13? This one here is 13. It doesn't have a left child. It only has a right child. So the option will be 16C, none. We do not have a left child for 13. Now, the remaining two questions have to do with the levels of the tree. And we just need to remember two very simple things. First of all, height. When we're measuring height, we go from the leaves toward the root. All leaves have height 1. So you first put a 1 in every single leaf that you have. For the nodes that are not leaves, the rule is your height will be the height of your tallest child plus 1. So for the 24 here, I have a 1 and a 1. The maximum between a 1 and a 1 is a 1. So 1 plus 1 will be a 2. 13 only has one child. So it's 1 plus 1 is 2. For 7, I have two children with different heights. I have a 1 and a 2. I pick the larger, which is a 2, and I add 1 to it, so I get a 3. So here I have a 3 versus a 2. 3 is bigger. 3 plus 1 is 4. I have a 4 versus a 1. 4 is bigger, so I get a 5. I have a 5 versus a 1. 5 is bigger, so I get a 6. And now I can't do this one because I'm missing the other branch. I only have a 1 here, so this is 2. I only have a 2 here, so this is 3. 3 versus 1. 3 is bigger. I have a 4. So now I have a 6 against the 4. 6 is bigger. I have a 7. So the height of the whole tree would be 7. But what's the question? The question is about what's the height of node 7. So it's this node here. So that node is at height 3. So that would be 17C. Of course, you could only do the heights up to the node that you're being requested. I did them for all of them now, so that in case you guys need to practice this, you can go over the entire drawing, looking at all of the heights. But the rules are really simple. If it's a leaf, the height is 1. If it's not a leaf, it'll be the height of the higher child plus 1. Then I'm going to use a different color for doing the depth. Actually, I'm just going to erase this and do the depth in a different picture so you guys won't be horribly confused, because the depth is going to be in a different direction. For the depth, we're going to start at the root and we're going to be going downward in layers. I'll draw this so it makes sense. I'm just removing the annotations that had to do with the height, so we get a clean picture for the depth. Okay, so depth will go from top downwards, and it works by layers. So the root will be at depth 0. Anybody who hangs from the root will be at depth 1. Anybody who hangs from somebody who's on depth 1 will be on depth 2. Anybody who hangs from a depth 2 node will be on depth 3. The ones hanging from them will be on depth 4. And now notice that the other branch, we're done with it. There's nothing here anymore. It had only 4 layers after the root. But this one continues. There's a layer 5, and there's even a layer 6. And how do you know you're doing this wrong? Right. The highest value for depth will always be 1 lesser than the biggest value for the height. Remember, the root had height 7. So the lowest leaf here is going to have depth 6. And why 6? Why not 7? Because the height started at 1 and the depth starts at 0. going to take a picture. So remember, when you want the height, you start at the bottom and you climb upward. When you want the depth, you start at the root and you go downward. When you want the height, you need to treat the branches separately because it's in terms of where the leaves are. And when you want the depth, you're just going by layers down from the root. So in question 18, we are requested for the depth of node 55. That's on depth 2. So 2 would be 18C. I'm going to reset the votes again, and you guys are going to vote green if you're okay with this binary tree stuff. And also, please send a direct message to the bot with all the keywords that come to mind about binary trees, all the things you think you need to remember about binary trees, so that I can check whether you guys have correctly understood what you need to study about binary trees. You can just look at my screenshot because this is really simple. You need to remember that we have keys that create nodes. Tree is going to be binary. Root's going to be the first node. Some of the nodes are going to be leaves. All the nodes are going to have a parent except the root. The root's the only one that doesn't have a parent. Anybody who is not a leaf has children. You can have a left child and a right child. All of the nodes will have a height. The height depends on the heights of the children. Leaves have height 1. All the nodes have a depth. The depth depends on how far they are from the root. The root has a depth 0. I'm going to take a screenshot of the last 2 pictures while you guys think about the binary trees. And once I start seeing the tag cloud of the words that come to mind about binary trees, we can talk about the last 2 pictures. Well, no questions, sorry. While you guys type, I'm also going to select the options we already know so that we only have the last 2 questions pending. So our graph had 8 nodes and it had 11 edges. We had an 11 over 28 as the density, 11 over 4 as the average degree. We had 3 edges in the induced subgraph. For the cycle, we didn't have any cycles. We had 2 possibilities for the maximal click. And for the independent set, we only had 1. The graph was connected, so the greatest connected component had 8 nodes. That distance was 12, for which the diameter has to be 19. And our spanning tree had a cost of 26. In the binary tree, the root was 59. We ended up having 8 leaves. The parent of 5 was 49. 13 did not have a left child. Node 7 was at height 1, 2, 3. It's at height 3. That's 17C. And 55 was at depth 2. So we know all of those now. Make this a little, yeah, okay, everybody seems to be doing well. Okay, so for the last 2 questions, we don't need the whiteboard anymore because these are not questions about drawing. These are questions about whether you understood the concepts in the study material. If you haven't been reading the textbook at all, please consider it. It's not very difficult to find in PDF, and it's a very good textbook. I'm referring to the Grimaldi textbook. If you already read it and your English is very fluent, also try to read the Concrete Mathematics one. That's a little more difficult to find in PDF, but I'm pretty sure it's on Russian torrents somewhere anyway. And if you have no books and no time to read books, at least read the webpage where the homework is, because most of these concepts are there. So these last two questions are about problems and algorithms that we have discussed, possibly in the homework or simply in the study material. For example, here, the question 19 that was randomly generated has to do with the vertex cover problem. So let's figure out how we can learn about the vertex cover problem. We would go here to teaching. We would go to discrete math. We would go to the web page of the study material. I'm just going to control F here. And I'm going to write cover. Okay, and then we're just going to click down until it says vertex cover. Okay, the vertex cover problem is the following. Given as an input a undirected graph and an integer k that's larger than 0, what we are requested to determine is whether there is a subset of vertices that has exactly k or less vertices in it, so that every edge in E has one of its endpoints in C. Okay, so what are the restrictions of the vertex cover problem? Not to repeat vertices. No, we're exceed weight limit. There's no weight limit. There's no source and target. There's no divisions. What was the thing that we were requested? That each edge had one endpoint. So here it says at least one endpoint has to be in the set. So each edge has to be covered at least once. And what's the output of binary search? Búsqueda binaria. Okay, so what do we do con búsqueda binaria? We are determining whether or not there is an element in the array. It's the thing we talked about in the homework. So it's going to be a true-false thing. It's going to tell you whether or not the element is there. It has nothing to do with traversing, nothing to do with reaching vertices, nothing to do with flow, nothing to do with the distance matrix. So it's just going to be true or false. And to practice for these two questions here, I've made you guys a little summary image that mentions the problems and the algorithms that we've been working with. And if you don't remember seeing them, just look for them in the study material so you don't have to memorize this entire table. Most of these are really easy. You just kind of like ignore the options that seem to have nothing to do with the problem and pick the one that is logically related and you should be fine. Okay, so I've answered the 20. Okay, I clicked something wrong. What did I click wrong? Left child of node 13. My node 13 didn't have a left child. Oh, this is the English one. Okay, it's a bug. It's a bug. Let me fix the bug. It's trying to look for an option that says ninguna, but it doesn't find one, so it thinks it's incorrect because it's none instead of ninguna. Let's go fix it. Now, if I could just remember what's the, it's process, there it says. Let's go grade better. So we want question 13. But this is the midterm. Question 13 in the final. Let's look at what we have in the data. Grading again, since it's a practice. No, I'm printing the wrong thing. Q is questions. Okay, let's look at Q. I think I'm printing at the wrong moment. Okay, this is, oh yeah, I'm counting wrong the question. It's the one that has to do with it's this one. It's because the izquierdo derecho, it's written in Spanish. It's not written as the left and right. That's why it's not getting it right. So there is a left. So I need to add an if here. And now I broke it entirely. Oh, it's because I'm using the pop. Okay. Chose is going to be D pop 0. So if chosen has hecho, all right. No, I didn't save it. Come on. It's always fun to watch me debug live. It still doesn't like it. Oh, I think it's because it's the... Okay, so cual. Let's print more stuff. Let's print cual D. Look at what's in D. Izquierda, 13. Let's look at cual, H, and CL. No tiene. Okay, so it says no tiene, and we have a none. So H, so let's make an OK. That will have an H, and if no tiene is in OK, we're going to also add none in OK. And then we're going to check if the response is in OK. Now we're going to look at OK. And we have 20 points. Okay, let's get the print away. Wait one more time, and we are good. Okay, let me print this for you guys. Sorry for the delay. No, we don't want to print it. We're saving it as PDF. It's going on the desktop as M4 PDF. And I can send it to you guys here. M4 PDF. There we go. So let's make a poll. Let's vote green on Discord on the poll if you think you know how to respond all of the 20 questions. Vote the confused face if you still think you need to study a bit more before you can do this. The question mark if there's some question that I would need to help you understand before we finish today. And the sleepy one if you just showed up and you don't really know what's going on. It would be great if you could type on Discord how many points do you think you're going to get. And then please use the remainder of the class hours today to practice the exam at least once. Since you don't have to explain to anybody what you're doing, you should be able to do it in like a half an hour or less. And remember, you can only use one sheet of paper. So separate half of your paper to clearly draw your graph, and then the other half of your paper to clearly draw your binary tree. Get a lot of colors so you can draw like different things on top of those drawings that you can check, like things like cycles and spanning trees without having to redraw the whole graph. And you can do calculations for depth and heights on the tree without getting horribly confused. So please practice this. Please post pictures of the sheets of paper you're using for the practice. Please post how many points you're getting in the practice exams. And please let me know now how many points you think you should be able to get. But this is a really easy class to pass because you should have all 50 points from the homework already. If you did very poorly in your midterm or you want a very good grade, then I really recommend you read the instructions for the project. And during today, write on the Discrete Math channel on Discord your proposed topic so we can register your topic. It is mandatory to register your topic. Si no has registrado tu tema de proyecto, no puedes entregar proyecto. Durante el día de hoy vas a tener que decirme en el canal de Discretas en Discord cuál quieres que sea tu tema. Sin registrar tu tema, sin tener mi visto bueno, tú no puedes entregar proyecto. The project is only worth 10 points. So if you did decently in the midterm, you probably don't need it. And if you don't want to get 100 on the class, you probably don't need it either. And you can just worry about your other classes. The other thing I need everybody to answer this little survey. So if you've done it, please ignore me. And if you haven't done it, please fill it in today. I would like to remind you all that the exam is on Tuesday. Next week, Tuesday. It's not going to be a Thursday, it's going to be Tuesday. So please make your preparations. Remember to have your student ID at hand, a clear picture, horizontally oriented, cropped to just have the credential on it. Please remember to have your one sheet of paper. You cannot use a calculator, you cannot use Python, you cannot use the book, and you cannot exceed the 90 minutes. So when you start the exam, please set an alarm to remind you like an hour and 15 minutes later that you're about to run out of time so that you will ask me for the grading pin code well before your exam will expire. Some people were really disorganized and let their exams expire in the midterm. Please don't do it again. If you have any questions, I am available here for you until noon to help you finish the homework, to help you understand all the exam questions. If the exam's giving you an error on a question, please send me a picture of your answer and of the question, and I can work out what exactly is the problem. Since this is the first time I'm applying the final exam in English, there might be more bugs like the one I just found. So let me know if you run into any suspicious behavior so I can debug it and fix it. Very important to practice so that we don't run into any technical issues in the exam itself. And if you guys don't have any questions, I will simply see you on Tuesday at 9:30, ready to go to pass the class. Remember that if somebody helped you and you use the MVP, they're going to get commission after we have finished the exam. The morning after the exam, I'm going to calculate the commissions because the amount of points that they get for having helped you depends on the grade you get. So we need to do the exams first. In a minute, I will give you guys the link to the Twitch recording from today. And I'm also going to start exporting it to YouTube so you can watch it there even later on. If you think you're not going to pass the class and you're going to need the second opportunity exam, please complete all your homework. It's the same homework. And please register your project. It's the same project. The only thing you will do in Extraordinario is present the exams again. There will be no further opportunity to work on the homework. You have to finish those now. There will be no further opportunity to work on the project. You need to get started with the project now if you need it for the second opportunity. Everybody take care and write on the channel if you need me.